Okay, so this is question 5 B from the 2011 scholarship paper, and I probably should have just tagged it in at the end of my video for question 5 part A because it's not actually that there's not actually that much to it, and it is relating back to it. But compound C from part A, the isomer had the molecular formula C4H6O4, and the structure worked out to be a compound which had an OH group or alcoholic group, and then it also had two carboxylic acid groups at either end of the molecule. So that's what the structure for compound C turned out to be. And then the question says, very short and succinct, discuss the potential for compound C to form polymers. So the potential here is that if you have two of them side by side, let's just use a different color. So if we have another one here, two carbons and a COOH group right there. Then we have this at the end of it, and then an OH group, and then a hydrogen. So the key point here is that to get to esterification, you need to have a compound which has two functional groups at either end, typically the same. So this here would be a dicarboxylic acid, for example. But the other thing about the dicarboxylic acid is the presence of the OH group. Now, what I initially started to draw was I started to link the two dicarboxylic acid monomers together, and that's not correct because you can't have the same functional groups attacking each other, of course. So the key here is that the OH group is going to attack one of the carboxylic acid groups at either end. So then this carboxylic acid group could attack another OH group on another monomer beside it. And this is the key to how this compound can form polymers. And if you have an alcohol group plus a carboxylic acid group, well, then you're going to form an ester link, and therefore you're forming a polyester polymer in this case. So let's just draw an example here. So let's open this molecule out a little bit. I'm just going to arrange it in this fashion. So use the brown color for the first monomer, and I'm just going to draw it like this. So the OH group is on the side right there, and then you have your hydrogen like this. So I'm taking it from a, it's turning it right angles basically, turning it up 90 degrees like this, and we now have the molecule sitting in this direction rather, down here like this. So then you have your carbon to your two hydrogens at the end, which is this carbon, and then you have your other carboxylic acid group. So that's your first monomer, and use a different color now. For the other monomer we had orange, so we have it beside it now. It has its OH group on here like this. Its carbonyl carbon is right there. Then you have your two hydrogens on it, which is this carbon right here. And then I'm just going to stick the COOH group on right there. I think I'm missing something there. Yes, I see what I'm missing. So I'm missing an extra carbon on here. So I didn't draw this correctly. So let's get this right. So we have another carbon, 1, 2, 3, and then 4. So we have our carbonyl oxygen right there, OH group right here, and then the other OH group, which is there with its hydrogen. So this is two versions of compound C. So just check, we should have 4 carbons, 1, 2, 3, 4, 2, 3, 4, 5 oxygens. That's not right. So where's the extra OH group coming from there? Take a look. So I've now seen the error off my way. So compound C was the molecular formula C4H6O5, and that will help things a lot here now. So we have 1, 3, 5 oxygens in there. So that's why that was 5, in case you were wondering what was going on. So a mistake there. But then that allows us to draw this compound right here with 5. And then what we're doing is we have the OH group here, and it's attacking one of the hydrogens from here. we're going to form our ester linkage then. And then the molecule becomes a polymer, which looks like this. So let's just scroll down a little bit more. Carboxylic acid group at the top, carbon with 2 hydrogens stuck onto it. Next carbon, oxygen, and that's going to link onto the other monomer. The carboxylic acid group is still intact down here. We get our orange color. And then we have our carbonyl carbon is still preserved, and that oxygen would have been there, so that's an orange oxygen. And then we have the rest of the molecule. And the loss there of H2O, loss of H2O, and this is catalyzed by acid. So this would continue. This carboxylic acid group could form an ester linkage with another alcohol group on another monomer right there. And this carboxylic acid group here, for example, could form an ester linkage with another OH group on another monomer, and then continues, and then you're forming a polyester. So this here is an ester linkage. So that's the potential for compound C to form polymers. Let's just take a look at the ncte answer. So compound C has 2 functional groups, alcohol and acid, in the same molecule, and this is what allows it to form polymers. Incorrect to say that the 2 carboxylic acid groups could interact with each other. This means that under the right conditions, they can form ester linkages with other molecules. We cover that. There are several places in each molecule where these linkages can form, allowing for a long chain to be synthesized. That's just an example right there, and it's acid catalyzed. And there's your ester linkage right there. So that's the answer to question 5b from the 2011 scholarship paper, and that's the last video now for the 2011 paper.